The story of human flight is one of relentless innovation. From the Wright brothers' first shaky flight in 1903 to the sleek supersonic jets of today, aviation has always been about pushing boundaries. But as we stand on the brink of a new era, the aviation industry faces its greatest challenge yet: how to reconcile our love of flying with the urgent need to protect the planet. The answer lies in a new generation of aircraft electric and hydrogen-powered planes that promise to revolutionize air travel while slashing emissions. This is the future of aviation, and it's closer than you might think. The problem: aviation's carbon footprint. Let's start with the problem. Aviation accounts for about 2.5% of global CO2 emissions, but its impact on climate change is even greater due to other factors like contrails and nitrogen oxide emissions. With air travel expected to double by 2050, the industry is under immense pressure to decarbonize. The problem is, traditional jet fuel is incredibly energy dense, making it hard to replace. Batteries and hydrogen, while promising, come with their own set of challenges. So, how do we get from here to a zero-emissions future? Electric planes, the short-haul solution. Electric planes are the low-hanging fruit of sustainable aviation. They're quiet, efficient, and produce zero emissions at the point of use. But there's a catch: batteries are heavy. Today's lithium-ion batteries store about 50 times less energy per kilogram than jet fuel. This means electric planes are best suited for short-haul flights, where weight is less of an issue. One of the most promising examples is Alice, a 9-seater electric plane developed by Israeli company Aviation. With a range of 440 miles and a top speed of 276 miles per hour, the Alice is designed for regional travel. Think New York to Boston or London to Paris. It's not going to replace long-haul jets anytime soon, but it's a glimpse of what's possible. Another key player is Heart Aerospace, a Swedish startup backed by United Airlines. Their ES-30 plane is a hybrid electric regional aircraft that can carry 30 passengers up to 500 miles on battery power alone, with a gas turbine extending the range to 800 miles. It's a stepping stone toward fully electric flight, and it's already attracting interest from airlines looking to reduce their carbon footprint. But electric planes aren't just about reducing emissions, they're also about reimagining air travel. Imagine a future where small, quiet electric planes connect rural communities, bypassing congested hubs and reducing travel times, or where urban air taxis whisk commuters across cities in minutes, powered by clean, renewable energy. This isn't science fiction, it's the future we're building. Hydrogen planes, the long-haul game changer. For long-haul flights where batteries are too heavy, hydrogen is the most promising alternative. Hydrogen is the most abundant element in the universe, and when burned in a jet engine, it produces only water vapor as a byproduct. But there's a catch. Hydrogen is tricky to store and transport. It's either compressed into a gas, which takes up a lot of space, or liquefied, which requires extremely low temperatures, minus 253 degrees Celsius. Both options add weight and complexity to aircraft design. Despite these challenges, several companies are betting big on hydrogen. Airbus, for example, has unveiled 3 concept planes under its Zero-E program, all powered by hydrogen. The most ambitious is a turbofan design that can carry up to 200 passengers over 2,000 miles, enough to cover most short and medium-haul routes. Airbus plans to have a hydrogen-powered plane in service by 2035, and they're not alone. ZeroAvia, a California-based startup, is already testing hydrogen electric planes. Their 6-seater prototype completed its first flight in 2020, and they're now working on a 19-seater model with a range of 500 miles. By the mid-2030s, they hope to have a 100-seater plane capable of flying 1,000 miles, enough to cover most domestic routes in the US and Europe. But hydrogen's potential goes beyond passenger planes. It could also revolutionize cargo aviation, where weight and range are critical. Companies like Universal Hydrogen are developing conversion kits that allow existing planes to run on hydrogen, providing a faster path to decarbonization. And in the military sector, hydrogen-powered drones and unmanned aircraft could offer longer endurance and lower emissions. The infrastructure challenge. Of course, none of this is possible without the infrastructure to support it. Electric planes need charging stations, and hydrogen planes need production, storage, and refueling facilities. This is where the real challenge lies. For electric planes, the infrastructure is relatively straightforward. Airports already have electrical grids, and charging stations can be integrated into existing facilities. The bigger challenge is generating enough clean energy to power them. Solar, wind, and nuclear power will all play a role, but will also need breakthroughs in energy storage to ensure a reliable supply. Hydrogen is more complex. Today, most hydrogen is produced from natural gas, a process that emits CO2. To be truly sustainable, we need green hydrogen, produced using renewable energy to split water into hydrogen and oxygen. This requires massive investments in electrolyzers, renewable energy, and transportation networks. But the payoff could be huge. A global hydrogen economy that not only powers planes, but also decarbonizes industries like shipping, steel, and chemicals. The role of governments and airlines. Transitioning to electric and hydrogen planes won't happen overnight, and it won't happen without government support. Policies like carbon pricing, subsidies for clean energy, and funding for research and development will be critical. The European Union, for example, has made hydrogen a cornerstone of its Green Deal, with plans to invest 470 billion euros in hydrogen infrastructure by 2050. The US and China are also investing heavily in hydrogen, recognizing its potential to transform multiple industries. Airlines, too, have a role to play. Many are already committing to net zero emissions by 2050, and some are going further. United Airlines, for example, has invested in electric plane startup Aerospace and signed a deal with ZeroAvia to purchase up to 100 hydrogen-powered planes. EasyJet is partnering with Airbus to explore hydrogen technology, while Icelandair is looking to leverage Iceland's abundant geothermal energy to produce green hydrogen. But the transition won't be easy. Airlines operate on razor-thin margins, and the cost of new aircraft and infrastructure will be steep. Governments and industry will need to work together to share the burden and ensure a just transition for workers in the fossil fuel industry. The human factor, pilots, passengers, and communities. At the heart of this transition are people, pilots, passengers, and communities. For pilots, electric and hydrogen planes represent a new frontier. The skills needed to fly these aircraft will be different, and training programs will need to adapt. But pilots are also excited about the potential for quieter, smoother flights and the chance to be part of a more sustainable future. For passengers, the benefits are clear: cleaner air, quieter skies, and the knowledge that their travel isn't harming the planet. But there will also be challenges. Electric planes, for example, may have shorter ranges and longer charging times, requiring changes to how we plan and book flights. And hydrogen planes, while promising, are still in the early stages of development, meaning it could be decades before they become mainstream. For communities, the shift to electric and hydrogen planes could be transformative. Airports could become hubs of clean energy production, generating jobs and economic growth. And the reduction in noise and air pollution could improve the quality of life for millions of people living near airports. The road ahead, challenges and opportunities. The road to zero-emission aviation is fraught with challenges. Batteries need to become lighter and more energy-dense. Hydrogen production needs to scale up and become more affordable. And the entire aviation ecosystem, from manufacturers to airlines to regulators, needs to align around a common vision. But the opportunities are immense. Electric and hydrogen planes could create a new era of aviation, one that's cleaner, quieter, and more accessible. They could open up new routes, connect remote communities, and make air travel more affordable. And they could help us tackle one of the greatest challenges of our time, climate change. Conclusion: a new chapter in aviation. The future of air travel is not just about technology, it's about vision. It's about imagining a world where flying doesn't come at the expense of the planet. It's about daring to dream big, just as the pioneers of aviation did over a century ago. Electric and hydrogen planes are more than just a solution to a problem. They're a symbol of what's possible when we combine innovation, collaboration, and determination. They remind us that the sky is not the limit, it's just the beginning. So, the next time you look up at a plane streaking across the sky, imagine a future where that plane is powered by clean energy, where the only thing it leaves behind is a trail of hope. That future is within our reach if we dare to reach for it.